This video is a section of a course. The course is C Programming for Beginners. The section is 06, Basic Pointers. Here are the lessons of this section. 6. Basic Pointers, 6.1. Memory Concepts, where variables are stored, 6.2. Pointers, pointers as variables that store the memory address of another variable, 6.3. Pointers, address of, ampersand, and dereference, asterisk, operators, 6.4. Pointers and arrays overview the relationship between array names and pointers, 6.5. Exercises, no answers. First, Introduction. Variables revisited. Throughout our course, we've used variables like integer age equals 30, without really thinking about what happens under the hood. We know that age holds the value 30. But where does this value actually live? The answer is, in your computer's random access memory, RAM. To fully understand pointers, we must first understand how this memory is organized. Second, memory. Think of your computer's memory, RAM, as a vast one-dimensional array of storage cells. Every single box, storage cell, has two fundamental properties: address and content. Address, a unique number that tells the computer exactly where the cell is located. This is usually represented as a large hexadecimal number, e.g., 0x7ff7, etc. Content, for the int data type, this memory box is one of the four parts of the data content of the variable. And for char data type, just need one memory box contains the complete variable value. Because int is 4 bytes, then we need 3 more boxes and char is 1 byte. When you declare a variable in C, the compiler reserves a certain number of adjacent boxes, e.g., 4 bytes for an integer. For example, the memory addresses will be 0x00, 0x01, 0x02, 0x03. It places the content 30 inside those cells. It assigns the address of the first box to the variable name age. Third, the printf function and memory. When we use the variable name age in our code like this, about the age variable, the operating system knows at least two things: its first address and its data type. I am speaking about the first address, and the OS knows the data type of the age variable to be integer, for bytes equals 4 addresses. When it knows what the first address is, it also knows the 3 next addresses from the first address. Because these 4 addresses are located next to each other, like 0x00, 0x01, 0x02, 0x03. If you know the first address is 0x00, so you can know the 3 next ones, 0x01, 0x02, and 0x03. You can get the value of 30 from these 4 boxes. Just only know the first address. The variable name, age, is just a human-readable label for a specific first memory address. When people say a variable has an address, they are referring to the first address. Fourth, memory terminology for pointers. Variable name, age. The label assigned by the programmer. Content, 30. The data stored at the addresses. Address, 0x7ffeef, etc. The unique location number in memory. The crucial point for the next lesson: every single variable has an address, and that address is just another piece of data, a large number. Fifth, conclusion and next steps. We have established the foundational concept. Every variable is stored at a unique, numbered location, an address, in RAM, and it contains some content, the value. In the next lesson, we will introduce a new type of variable that exists solely to store those first addresses. Our next lesson is 6.02. Pointers. Pointers as variables that store the memory address of another variable. First, introduction. The address is just data. In the last lesson, we established that every variable, like integer age equals 30, has a unique memory address. That address is simply a large number, usually represented in hexadecimal. The key idea of this lesson is, if an address is just a number, we should be able to store it in a variable. Second, what is a pointer? A pointer is a special type of variable in C whose value can be the memory address of another variable. A regular integer variable stores an integer value, 30. A pointer variable stores an integer's address, 0x04. This is why pointers are sometimes called address variables. They point to where the data is stored in memory. Third, declaring a pointer the asterisk. Since a pointer is a variable, it needs to be declared. When declaring a pointer, you must use the asterisk operator. General syntax. Data type asterisk pointer name. The type is crucial. The data type in the declaration does not specify the pointer's own type. All pointers store memory addresses. Instead, it tells the compiler, this pointer points to a variable of this type. Integer asterisk PTR number. A pointer that points to an integer variable. Char asterisk PTR char. A pointer that points to a char variable. Float asterisk PTR price. A pointer that points to a float variable. This type information is vital because it tells the compiler how many bytes to read or write at the stored address, e.g., 4 bytes for an integer, 1 byte for a char. Fourth code example. Declaring and initializing pointers. Let's look at how we declare and initialize a pointer in context. We will use the addressive operator ampersand for the first time, as it is mandatory for initializing pointers. Fifth, summary. The pointer's role. The pointer variable ptrage has its own address in memory, just like any other variable. But the content of ptrage is the address of age. This indirection, storing the location instead of the value, is the core concept of pointers. We use the addressive operator, ampersand, to find this address. Our next lesson is 6.03. Pointers, addressive, ampersand, and dereference, asterisk, operators. One. Introduction to essential tools. In the last lesson, we learned that a pointer stores an address. But how do we get an address in the first place, and once we have it, how do we use it to access the actual data? The answer lies in 2 unary operators. The addressive operator, ampersand. The dereference operator, asterisk. These 2 operators are the core of pointer manipulation in C. 2. Operator 1. Addressive, ampersand, getting the location. The addressive operator, ampersand, is placed before a variable name. It returns the memory address where that variable is stored. Think of it as asking your computer, where is this variable located? Code example for ampersand operator. Key takeaway. The operator ampersand is used to initialize a pointer by giving it the address it needs to point to. 3. Operator 2. Dereference, asterisk, following the map. The dereference operator, asterisk, also called the indirection operator, is placed before a pointer variable. It accesses the content, the value, stored at the address contained within the pointer. Think of it as asking your computer, what value is at the location pointed to by this address? Using asterisk operator to read data. Once PTR holds the address of number, asterisk PTR becomes an alias for the variable number itself. 4. Using asterisk operator to modify data, crucial concept. The real power of dereferencing is that you can use asterisk PTR on the left side of an assignment operator to change the original variable's value indirectly. When you change asterisk PTR, you are directly modifying the content of the number variable in memory, even though you never used the name number in the assignment. This concept is fundamental to passing variables to functions by reference, call by reference, which maybe we will explore later. 5. Summary and next steps. You have now learned the basic declaration and operation of pointers. Our next lesson is 6.04. Pointers and arrays. Overview the relationship between array names and pointers. One. Introduction, arrays and addresses. We know that an array is a collection of elements of the same type stored in contiguous, adjacent memory locations. For example, when we initialize integer ARR sub 5 equals 10, 20, 30, 40, 50, the 5 integers are stored right next to each other in RAM. Today's lesson reveals one of the most fundamental truths in C. In C, arrays and pointers are almost the same thing. 2. The array name as a constant pointer. When you declare an array, the array name itself acts as a special type of pointer. The rule, the name of an array, without brackets, is a constant pointer to the address of its first element, index 0. Consider this array. If we print the address of the first element and the array name, they will be identical. Key difference. An array name, ARR, is a constant pointer. This means you cannot change the address it points to. 3. Pointer arithmetic. Navigating the array. Because the elements of an array are sequential, we can use simple arithmetic on a pointer to move from one element to the next. This is called pointer arithmetic. If PTR points to the start of the array, ARR sub 0, what happens if we add 1? The C compiler is smart. When you write PTR plus 1, the compiler doesn't just add 1 byte. It adds 1 times size of integer for bytes, ensuring the pointer lands exactly on the next integer. 4. 2 ways to access array elements. Since the array name is the address of the start, we now have 2 equivalent ways to access any element in the array. Method A, array indexing, the traditional way. This is what you're familiar with. Method B, pointer dereferencing, the pointer way. This uses pointer arithmetic and dereferencing. Conclusion. The compiler treats the traditional array indexing ARR sub I as syntactic sugar for the pointer expression asterisk, ARR plus I. They are functionally identical. 5. Pointers and function arguments, call by reference. In C, you can pass its address, the pointer to its first element, to functions. When you define a function that takes an array, the parameter must be declared as a pointer. In this context, the parameter integer asterisk is an adjustable pointer that holds the starting address of the data array. 6. Conclusion and next steps. The relationship between pointers and arrays is symbiotic. The array name provides the starting address, and pointers allow flexible, powerful navigation through the array's sequential memory blocks using pointer arithmetic. This completes our foundational lessons on C pointers. Our next lesson is 6.05. Exercises, no answers. Problem 1. Given the following data. Change, increase or decrease, the value of the data variable A through the pointer variable in at least 3 different ways. Not 3 different ways like that. Hint. P equals ampersand A. A is a variable and ampersand A is to get the address from a variable. Next, integer value equals asterisk P. P is a variable. This variable has data as an address. When you write integer value equals asterisk P, it is equivalent to writing integer value equals A. That is, asterisk P is the embodiment of variable A. Problem 2. Given the following data. Use the pointer variable P2 to access the value of the pointer variable P1 to get the value and memory address of the data variable A. Problem 3. Given the following function structure. Add a complete myReference function to perform the request to return the memory address of the ref variable. Additional knowledge. Integer asterisk function name. Return integer pointer value. Problem 4. Describe the meaning and operating principle of the concept pointer-to pointer from the exercise below. Use the pointer variable P2 to interact with the pointer P1 to get the value and memory address of the data variable A. Additional knowledge. Integer asterisk P1 equals ampersand A. P1 is a level 1 pointer. Integer 2 asterisks P. P is a level 2 pointer. Integer 3 asterisks P2. P2 is a level 3 pointer. A level 2 pointer can contain a value that is the address of a level 1 pointer. A level 3 pointer can contain a value that is the address of a level 2 pointer. Problem 5. Lesson 1. All operations on array A must use a pointer variable to process. Given the following suggested code. Write a program to perform the following requirements. 1. Output the elements in array A. 2. Output the odd elements in array A. 3. Calculate the sum of the elements that are prime numbers in array A. 4. Sort the elements in ascending order. 5. Delete the elements that are perfect squares.